Thank you, Michael, and good afternoon, everyone. Today I'm going to provide a background on the U.S. electrical grid, and then I'm going to go into some of the drivers for the smart grid in the United States and what we think the smart grid will look like, the U.S. government's role in smart grid, and in particular the role that NIST, or the National Institute of Standards, is playing in smart grid. Before I begin, originally I was going to give you a small quiz, and that quiz went something like this. The National Academy of Engineering some time ago announced the supreme engineering achievement of the 20th century. And then I was going to say, so is it, what is it? Is it the internet, the wireline telephone network, the cell phone, or smart grid? And of course we know, because Guido and Russ already said, it was the smart grid. So Russell and Guido, I've decided that if we had the smart grid today and we were connected to that, not all three of us would have come up with those same slides. So anyway, but it is pretty incredible, and this is what we're looking at improving. Now I'd like to share a few facts about the U.S. electric grid. So in North America, we have 3,200 different electric utility companies. We have 17,000 power plants, 165,000 miles of high voltage lines, 6 million miles of distribution lines, 140 million meters. So what does that do for my life? And it makes it it complicates it. So as you can see, this is, in the U.S., our grid is a very complex system of systems. So it complicates the development of an end-to-end interoperable smart grid. So it makes it pretty messy, as I said. So now I'd like to also talk a little bit more about today's electric grid. And, you know, things have changed a little bit over the last 100 years or so, but much of it's still the same. We still have the one-way flow of electricity. We have centralized bulk generation. It's responsible for 40% of human-caused CO2 production, but I guess that's probably increased over the years. We have currently controllable generation and predictable loads. Again, that'll be changing. Limited automation and situation awareness. And again, there has been some improvement on that. We still have a lot of customized proprietary systems in our grid, and I think everyone does. A lack of customer-side data to manage and reduce energy usage. So those are some of the things that we want to kind of improve on and change. So when I look at the smart grid, say what is it? What are the real drivers for the smart grid? I see an increase in system efficiency and cost effectiveness, and I should say that these are a lot of the drivers that every other country has been talking about, which I'll touch on that a little bit later. Provide customer tools to manage energy use, improve reliability, resiliency, and power quality, and enable use of innovative technologies, including renewables, storage, and electric vehicles. So now I'm going to talk a little bit more about each of these drivers. So when we talk about increasing the efficiency, again, that's clearly a key priority. And as you can see by the diagram up there, in the U.S., half of our generation today is produced by coal. And what's kind of interesting is you look down there at the first bullet point, half of our U.S. coal plants are greater than 40 years old today. So they're going to need to be replaced soon. The average substation transformer age is more than 40 years old. And the projected investment to modernize and expand our grid is estimated at $1.5 to $2 trillion by the year 2030. So we see smart grid as being an enabler to really help utilities reduce delivery losses and for customers to reduce both peak and average consumption. So basically what this means is we think we can continue to push out that investment out beyond 2030 with the use of smart grid. So earlier, right after lunch, someone was asking me, well, what is all of this smart grid? Why are we really doing this? So here's a pretty good reason why we're doing this. Now I'd like to talk a little bit more about improving reliability for the 21st century, and Guido Bartel talked a little bit about this. but you can take a look at the power outages that we have in the U.S. So it averages about just about a little bit over 2 hours a year per consumer. But that cost is equivalent to about $80 billion, and I have seen estimates up to costing our economy up to $150 billion per year. And of course, we're hoping as we continue to add sensors and automated controls in our grid that will certainly improve the reliability. Another driver, of course, is enabling a greater use of renewables. And clearly, with a greater use of wind and solar, requires more dynamic grid control and storage, really to keep that grid in balance. And just as an example up there, we've got a graph from a transmission service operator up in the Northeast in the U.S. And you can take a look at those lines of the red line is the load line, and the blue line there is their wind generation. And of course, you can see just as a load is peaking out, the wind has just dropped way down. So clearly, with that kind of dynamics, we do have to have smart grid to help manage that. Another key driver for us is enabling reduced dependence on oil. And so it's estimated that the idle capacity of the power grid today could supply 70% of the energy needs of today's cars and light trucks. It would displace half of the U.S. oil imports, reduce carbon dioxide by 20%. So that clearly is a big key driver. And what's kind of interesting, every time our gasoline price goes up, and it just peaked up to around $4 a gallon, there's really an interest in renewables. And when it gets back down to about $2.85 a gallon or whatever, then everybody forgets about renewables. But right now, it's on everyone's minds. So what will the smart grid look like? And I'm just going to kind of click through these. Oops. So, we see dynamic pricing. The smart grid will support dynamic pricing, energy management systems in the home and buildings, the high use of variable renewables, distributed generation and microgrids, distributed storage, bidirectional metering, electric vehicles. We talked about network sensors, smart meters, real-time usage data, and smart appliances. So that's what we see what the smart grid will eventually look like. Now I'd like to talk about architecture and standards in the smart grid. And really, these provide the foundation from my perspective. And of course, I want to talk about standards since that's my role. But really, standardized architecture, concepts, data models, and protocols are essential to achieve interoperability, reliability, security, and to really evolve that new smart grid. So those really provide the foundation. We've already seen this slide 3 times now, and I'm not going to talk about it anymore, other than to point out from my geeky background here that our Secretary of Commerce, Gary Locke, pointed out that we need standards for the smart grid. And I laugh because most of the technical people, you never hear about technology standards. I mean, it just, you don't read about that in the Wall Street or anything, but or the Financial Times, but here it is. So we did get a little bit